Kia ora, Year 12. I just realised I've left off the last half of question 5, which is a very exciting hypothesis testing problem. So we're going to do that now. So we've got a geologist who is looking at some rocks in another area. Apologies to all geologists out there. I'm sure it is very exciting. Anyway, the rocks in another area have got a mean mass which is less than 14.2 kilograms. So he or she wants to test this, and a random sample of 100 rocks has been taken, and those rocks have got a sample mean of 13.5 kilograms. So we're going to do a hypothesis test at the 2% significance level, and we're going to assume that sigma is still equal to 3.1. So let's start by setting up our hypothesis tests, our hypotheses. So H0 is that the population mean is equal to 14.2 kilograms, and we're doing a one-tailed test. We've got a clear alternative, which is that the mean mass in the other area is lower, so it's got to be less than 14.2. If you don't want to write mu and you want to write mean, you need to make it really clear that you get what you're doing, which is testing not just the sample mean, because we know that, we're testing the population mean. All right, so now we're going to look at what we've got in our sample. There are several ways to do this test. I'm just going to do one of them here. So the sample mean is equal to 13.5. We've got 100 rocks in the sample, and sigma is equal to 3.1. So I'm going to set up a test statistic, which is saying how many standard deviations away from the mean am I if the null hypothesis is true. Okay, so we get 13.5, and we subtract the mean under the null hypothesis. So this works out to be negative 0.7 over 0.31, which is negative 2.258. So before we mechanically go on, let's just think about what that's telling us. What that's saying is, if the population mean really is 14.2, how many standard deviations away from that is our sample outcome of 13.5? And so we can see that it's down here in the tail. So it's not very likely, but we have to now go and compare that to a critical value to see whether this negative 2.258 is so unlikely that at a 2% level we can reject the null hypothesis. So we've done the test statistic, and now we're going to go and get a critical value. So we do that using our tables, and we're doing a one-tail test. So we're saying, what is the number that's going to cut off 2% in that lower tail? And using your tables, and you're going to need to work backwards, you get negative 2.054. Okay, so we've done that quite a lot in class. If you've got trouble getting that value, make sure you send me an email or leave me a comment. Okay, so that's using the tables backwards, and now we're going to compare this number and this number. And we're in what we can call the rejection region, right? So negative 2.258 is less than our critical value. We're going to reject H0 and conclude that the mean weight, I'll say it again, mean mass in this area is below 13.5 kilograms. In other words, we do have enough evidence to say that in this area the mean mass is lower than in the other one.